Welcome to Data and Marketing Nation, the podcast that keeps busy professionals like you up to date on all things connecting data and marketing. My name is Dimitri Visnadi, and I'll be talking with experts to help uncover innovations, ideas, and insights. So let's go! Hey Christoph, I still wish you a happy new year. I know it's a few days have passed since the year has started, but still, thank you so much for joining the podcast today.
Yeah, thank you. Happy New Year to you too. It still feels like the beginning of January, and I realize it's already mid-January. Yeah, and thanks for having me.
Yes, and I hope you don't have too high, I don't know if you set up any New Year's resolution, any plans for the year, anything that you want to achieve, accomplish, I don't know.
No, but we have this thing that all the things that we thought we would then, after we close our December quarter, all the things we wanted to do quite at the beginning of next quarter. And now we realize that already we're in the mid-January. So it feels like the restive time of Christmas and New Year's has already passed by this time.
That's good. Perfect. Today's topic is Geo-experiments, and you're, let's say, the expert on that. And before we start talking about Geo-experiment, maybe you can give a quick intro about your background and your current role at Google.
Yeah, so I'm a data scientist in Google's Hamburg office. Maybe one thing I should say that because I don't officially speak for the company, so everything I say here, all my opinions about different data science tools or physics or anything are wholly my own. I don't speak for Google. We should say this at the beginning. I've been working for Google since more than 12 years. I first joined in London as a software engineer, then became a data scientist, transferred here to Hamburg. I'm a part of a team in ads engineering that devises the algorithms that underlie a lot of our analytics and measurement tools. So we're part of the Analytics, Insights, and Measurement organization. And I've worked until a couple of months ago, worked primarily on Geo-experiments.
Oh, interesting. And quickly talking about data science, you've been now a data scientist for quite some time, if I saw your LinkedIn profile. How would you just quickly say, before we jump into Geo-experiments, how would you exactly describe how the field of data science has changed when you started and how it is right now?
Yeah, so actually our ladder has only been called data science since a couple of years. We used to be quantitative analysts, and I'm actually the team that's mostly composed of statisticians. I'm actually a theoretical physicist by training. Long ago, worked on high energy physics and computer simulations, and then in between worked as a bioinformatician. So I became basically a data scientist before we used the word data scientist. It still feels somewhat fresh, especially at Google. It's still, I think most people consider it a combination of, well, there's statistics, there's machine learning, and there's software engineering in there. And there are different parts coming in. And so in our teams and the projects we work on, like the Geo-experiments or the experiments in general, it's more statistics. But especially in my role, I usually work with larger data sets. So many of my statistician colleagues focus often more on R. I always liked working with the larger pipelines of machine learning algorithms. Machine learning is coming in. Machine learning and statisticians are always an interesting, or machine learning statistical problems are always an interesting combination. But I think in general, data science is this mixture of like these three disciplines, and probably different people put different emphasis on different parts of it.
But you would say that generally it's a good new name for the task.
Yeah, it actually characterizes it better than the old names. The problem was always that we were called quantitative analysts, but analysts is in many places a low-level title. So it's the entry title in most consultancies and business. So we were never terribly happy with the word analyst. And since I didn't study statistics, I can't call myself a statistician. They're very strict about that. And so data scientist was actually a nice cover for a whole area of things that we were not able to do 20 years ago.
Yeah, I understand. And especially now with the computing resources and all the tools now that are available, things have changed over the last 10 years, I think, a lot. Yeah, slowly getting towards our topic of Geo-experiments. But just one thing I want to say before is, from our last conversation, I remember is that you don't work on the commercial side of the products, but you basically are more focused on the theoretical part of it, the science behind it. Is that correct? Or?
In some sense, though, but actually the algorithms we develop are in use. So we work directly on the product in some sense, but we have these different layers. And that's actually the nice thing about being a data scientist, is that you actually cut through the whole amount of layers. So you have on one side, we work with the engineering teams that actually build the products in the end. Then there are also the teams that work closer to the client, but are like 2 or 3 levels usually. So we have people who are directly working with the clients. They then have specialists for measurement or analytics. And above that, there's also teams who do the product management or product leads, connect us and the engineering team to the actual users, which in our case are either the clients, our advertising customers, or the teams that work directly with the clients. So our team focuses on development of the methods that are then used in the products, but they're directly used in the products. So we're not publishing, or we publish papers, but we're not just publishing the papers. We really want our algorithms to be in the hand of the clients.
Interesting. Very cool. Yeah. So I remember you gave a talk about geo-experiments. I found that very interesting. And before I ask any deeper questions, what are geo-experiments in your own words?
Yeah. So our problem is figuring out whether advertising works. So usually I say at that point that for us, it's clear that advertising works because we get paid a lot of money to do advertising. But our clients might want to have a stronger motivation to actually give us the money. So there's a fundamental question in marketing science whether advertising actually works. We know that it works in some sense because it's really like it's an established field and we know that makes a difference. But we, especially if you do campaigns online, you would like to be able to figure out which campaigns work better than others, which audiences, which countries work better than others. So there has been a long scholarship figuring out actually how to measure the effectiveness of advertising. In general, that's if you don't have computers, that's even harder because when you do classical advertising, like TV advertising, newspaper advertising, advertising on billboards, it's extremely hard to figure out if they have any effect because you don't know which people see that. You don't know how these people behave. So when with online advertising, we suddenly have the ability to do measurement and figure out whether advertising actually changes customer behavior. And geo-experiments are one way to do that.
Okay. And would you say that geo-experiments has anything to do with attribution modeling? Because if I just imagine the core Google AdWords product for advertisement, and I'm a simple marketer, I spend my money, I create some advertisement, users see it, they maybe click on it, they go to the website, I assume Google Analytics will track it and so on. So it's more about attribution. So what's geo-experimentation compared to attribution?
Yeah, so different in experiments, we want to measure the actual causal effects of advertising. The problem is that advertising, so we have a computer that decides who is being shown ads. And this computer is actually very good in deciding. It's trained to show ads to people who in the end will convert. So they click on something or they buy something, and it knows which kind of people will click on something and buy something. And this computer knows we are being paid when somebody clicks on something or buys something. The problem is the computer doesn't care whether that person is influenced by the ad or is just a person who will anyway buy the product. So there's the risk that these ads are being shown to the people who anyway buy the product, because that's a perfect success for this computer, for our computer. But for the advertising, you actually want to show it to people who would, without seeing the ads, not buy the product. If you do attribution, you basically look at the first thing. Somebody sees the ad, somebody buys the product. You sort of assume that if they had not seen the ad, they would not buy the product. For performance ads, there's some reason to say that because you only care about online sales. You can actually see that most people will probably come through your ads and will come directly to the website, but you can measure that. So you would be able to disentangle that. But for most products, you have advertising on several different channels. Online advertising is only one of your channels. If you do attribution, and the other thing is that your sales channels might not be online or might not be directly online. So people will see the ads on some YouTube and a little bit later they click on something. But did they go to your website because they saw the ad? Or were anyway interested in buying your product? And so experiments disentangle, attribution cannot disentangle that easily. So experiments really try to measure the incremental value of your advertising.
And now the geo part of it, of the location side, how does that basically play a role in it?
So the problem is, we talk about experiments here. So we have A/B experiments that we do in cookies, where we basically decide based on a cookie user had whether they are in the exposed group or the withheld group. So an experiment also means that you want to compare people who don't see the ads to people who see the ads. It also needs to be a randomized experiment because you want to have these groups as similar to each other as possible. So you want to have the same kind of people, and some of these people will see the ad, some of these people won't see the ad. And then in the end, you can sort of see the difference the ad made. So that's the causality aspect. The easiest way to do that, and that's why in online advertising that initially was so easy, is to use the cookie. So whenever a user comes to the website where an ad could be shown, we look at the cookie and they randomly decide whether this cookie will be in the treatment or the control group. And if it's in the control group, so a group that doesn't see the ads, they will stay in this control group as long as they have the cookie, which can be quite long. So that's easy. The problem is that cookies are going away. That's one of the problems. Cookies are going away, and they're privacy invasive to some extent. So we want to be able to do experiments without having the need of using a cookie. So what we do is, instead of looking at the cookie of the user, we look at the location of the user. It's also an attribute of the user. Then we pick some locations that are part of the exposed group and some locations that are part of the control group who doesn't see the ad. So in the end, we show the ad in some regions. We don't show the ad in other regions. Then we compare the outcome in these two regions. In some sense, it's still a randomized experiment because we try to keep these regions random. So the people in the exposed regions and the people in the control regions are still quite similar. So basically, it's an experiment as your A/B experiment, but it's based on geography and not based on your cookies.
Okay. And basically, with regions, it could be, say, one country or another country. It could be within a country, a specific region within a specific country, or however you define basically region, correct?
So that's sort of the problem there. As I said, the main thing about the randomized experiment is that you basically choose the people who are in the treatment control groups randomly. So if you, for example, take randomly Germany and randomly the Netherlands as treatment control, you actually have only Dutch people in one group and only German people in the other group. That's not good. So what we try to do is we choose geographical regions that are smaller, and actually as small as possible. So we take a region of 100 kilometers diameter in one place, and then the next 100 kilometer will be the other group, and then we randomly assign these groups to treatment and control. Sometimes bigger cities, sometimes rural areas will fall in these regions, but since we have enough of these regions, and then we randomly choose the ones that are in treatment and control, we can be relatively sure that, we can say it's unlikely that the resulting experiment groups are much different. So they're likely to be very similar. In the project, for example, I worked on recently was designing the size of these geographical regions.
And during this experimentation, at the end, you basically obtain the result if a specific advertisement campaign material has performed well or not.
Yeah, essentially, we sort of show the advertising in some regions, don't show it in other regions. Then we compare if there's a difference in the behavior of the sales curve in the treatment compared to the control.
Because you could have an advertisement that maybe converts well to the website, but actually no sales are generated afterwards, for example. So
that's a nice thing. Since it's geographical, you can measure, for example, offline conversions. It's actually one of our main applications, which means brick and mortar stores. So in one of the kinds of experiments that we do, these are based on what used to be called local campaigns. I think it's PMAX campaign for conversions for local, something like that, where you can actually target the people living around individual brick and mortar stores. So that's typically be done for large retail chains that have like 50, 100, 200, thousands of stores. And we can basically target the region around each store in AdWords. And then when we do the experiment, we will take a group of stores where we show the ads, where compared to a similar group of stores where we don't show the ads, we get sales numbers from the clients, so the actual sales at the cash registers. Then we hope that we can detect little rise in sales in the regions where the advertising is being shown. In theory, you could even combine that with advertising in newspapers or advertising on billboards to measure the effectiveness of these kinds of advertising. So it's quite nice because it's one of the few ways you could actually look at the efficiency of online advertising for the offline world.
Yeah, that basically bridges that problem that most advertisers probably have, because maybe in the past you need also some statistical models, but again, most companies, they invested in, billboards and metro stations or subway stations, and at the end they didn't really know what effect did that have? Did that have an effect on the brand, or did it really have some direct sales impact? So
yeah, I mean, actually, we also had one client who was looking at the effect of the Postwurfsendung, the flyers that you put into the post boxes of people. But yeah,
And,
it's we call it then sometimes O2O, online to offline. So it's this question if there's the online advertising affects the offline world, which is getting more and more interesting.
okay. And now you always mention that this is how you run the geo-experiments. What if someone else wants to run them? Can anyone run them? What, let's say, tech do you need? What knowledge do you need? How can you execute such geo-experiments? Or can only, let's say, you at Google do that?
No, so yes, in principle, it's something anyone can do, even using Google tools. So in AdWords, you can do geographic targeting. So people can set up geographic experiments in a sense by just targeting certain regions of a country if they sort of have a map to do that, and then do the analysis. So there are several tools online available. So we have a tool called Trend Match that's being used then for the analysis of the experiment. Colleagues from Facebook also have a tool. A lot of people publishing math and also R packages and Python packages in this area. And then you do the experiment, and basically you look at your sales numbers, either online clicks, where you also can see the geos where they come from, or offline sales, and then in principle you can analyze that. But Google is also sort of starting to offer geo-experiments as an online tool. So in 1 or 2 quarters, it's supposed to be in our AdWords products. In the moment, people usually run online experiments with us by talking to their dedicated client teams, and sort of the experiment is set up internally by an industry manager they're working with.
And how would that work basically compared to the world of marketing mix modeling? Does it have something to do with that, or am I stepping out of the zone just for throwing it in there?
Actually, our team also works on marketing mix models, so that's a big thing. So I'm not an expert in that area, but it's related in the sense that you look like at the macroeconomic numbers. So your sales, you look at in geo experiments, you look at the spend in each region, and then you correlate it with the revenue from these regions. So whereas in most online experiments, you basically look at the conversion probability and things like that. So it uses these macroscopic data. I'm not sure MMM usually is not an experiment, but it's observational. So because you just compare the different curves, and there are people. I think you could argue that geo-experiments in some sense is like marketing mix modeling when you do a geographical experiment, or if you compare different regions. So in that sense, it's quite related, and I think both topics are trending at the moment. And I know also there are people looking at the similarities if you can sort of combine the two techniques.
Yes, that's why I kind of throw it in there, because I know right now in the last month, I think Google published a new package around mixed modeling. I think there's the Facebook Robin, that's already an older one, I think written in R. So I think there's a little bit more conversation around that topic.
Yeah. So the MMM, I think, comes from our wider team. So it's a similar team here, but I think at least that's the one that has been out now recently. So some people are working on that. So we are a team, as I say, our team is sort of the data science team for all analytics, insights, and measurements at Google. So a lot of the algorithms, not all, others, then end up with our wider team. And we're about 60 or 70 people spread over the whole world under one director that does sort of a data science for this area. So we traditionally have been doing all of these things and a few more things.
I think most tools that are out there today, like Google Analytics and even all the advertising platforms, doesn't matter if it's like from other competitors of yours or your own AdWords tools and so on, I think they already provide great set of features to run valid experiments. However, I think in order to run a good and again, as I said before, a valid experiment, you need a little bit the know-how on how to actually design an experiment, which I feel like most people don't have, because it's actually very difficult to design a good experiments and keep all the limitations in mind.
Yeah.
Do you have any suggestions on that or any thoughts?
It is hard. I mean, some of the last Nobel Prizes in economics were given for people working on experiments. So usually it's for the analysis of like economic quantities, but a lot of the research is relatively young, and it is statistically challenging to actually figure out whether your experiment is valid. So the basic idea in our algorithm is always that we look at the past. So we think the past, we assume we have data where there is no experiment running somewhere in the past. So if you look at the data in the past, in principle, we analyze them using the same way we would analyze the outcome of the experiment. And then we look at the past of the experiment running, so you should see zero effects. But of course, it's never zero. There are fluctuations in there, of course. So you compare, you set up your regions and you compare like the last year. If I look at the sales in one region and the other region and compare them using the algorithm, how much lift do I see in one region or the other? And obviously there shouldn't be a lift, there should be equal, but they're not. And this gives us basis of the distribution that we have to beat. So that's basically then the significance bars that we need to sort of get. And we spent actually more of my statistician colleagues spend a lot of time figuring out how to derive that significance threshold. So what's the minimum effect you can detect in an experiment? And of course, there are so many things that can go wrong. So you basically look at what happens between the two groups. So retailers know that the retail sales can be massively different in summer, in autumn, in winter, and spring. Especially if you sell products around Christmas. They can be regionally different. Your advertising is not always the same. It changes. Sometimes it happens to be more advertising in one region, and other cities are different from rural areas. So there are a lot of things that can come in there. And there is a certain risk that you run an experiment and you see something positive, and that might be just a fluke. Even worse, you see something very negative, which in theory, if you take the experiment serious, it means that you actually managed to drive customers away, which is relatively unlikely. But I mean, if you really see a significant negative result, if you say significant, we think it's not random. So you really have to sort of be careful in the interpretation. So I remember I was asked some time ago, what's the difference between statisticians and data scientists? And what I said is that statisticians are the ones who say no. So the main role of a statistician in these analyses is to tell people, yes, it looks like there was a result, but it's not significant. And that's also a difficult role, and that makes experiments so difficult compared to attribution, is that actually a lot of the time the outcome of the experiment is not significant. So that doesn't mean there wasn't effect, it's just hard to measure. And if you think that even if you do a lot of online advertising, and we had clients who were running supermarkets, like if I do supermarket shopping, it's basically a fixed shopping list every week. And then if there's an effect of advertising, even if I buy something that I see on ad for, it's probably a percentage change in my weekly spend there. So it's a relatively small change in your revenue, even if you have a lot of advertising, because people spend the same amount every week. And that's really hard to measure. And then depending on Christmas, people buy more chocolate. And of course, you also run more ads for Christmas chocolates. But is that a causal effect? And then really finding out whether that's a causal effect, that's quite hard. So that's sort of my caveat that for experiments, it is difficult to know whether your result is significant. And you need probably to talk to a statistician about that.
That actually reminded me a little bit on my times at uni, also in one class where we discussed also the correlation or the relationship between buying diapers in a supermarket increases the chances that someone buys beer with it together. So again, in order to kind of come up with those results, as I said before, in an experiment, there are so many confounding variables that can basically have an impact on the results. And coming quickly back to the Geo-experiments we mentioned at the beginning, I still remember from your presentation about the Geo-experiments that there are things, for example, where your two groups, you try to test a specific advertisement in one region, but maybe a user that is from the other region might migrate or move over or travel over to the other region and basically gets impacted and then moves back to its region. It's little things like this.
Yeah. So that's actually, that's something I really like to talk about, because that's sort of the work I put in there. And that's also one of the more difficult things. So in an experiment, you would preferably like to keep this experiment group separate. So in medical experiments, which is like the gold standard, you try to figure out whether a medical intervention taking a drug works. You really want to make sure that the people who are the treatment groups, who are actually getting the drug, and the people who are in the control group don't get the drug. Otherwise, your effect is diluted. So in online experiments or in marketing experiments, you would like to make sure that the customers who see the ads over like the 4 weeks or 6 weeks that we do experiments are not seeing the ad at all, and the others see the ad. So as I said, we decide whether people are in the treatment or control group based on where they are in the moment when they look at the ad. The advantage of the Geo-experiment is you don't have to track people. So you don't need to know if it's the same person getting the ad serve request again and again, but we just look the region. Fortunately, people move around, which means we call that contamination. That's sort of a term for medical experiments. It can happen that somebody is for 1 week in one region, and then they travel to the other region for the weekend, or even just for work if the regions are close. And then for half of the time of the experiment, they're in the exposed group, for half the time they're in the treatment group. So it doesn't work anymore. They dilute the experiment, they reduce our return on advertising spend, the quantity we calculate. So the challenge with the Geo-experiment is to choose regions that are large enough so that people don't travel that frequently from one region to the other. And on the other hand, we try to keep our regions, of course, as small as possible. I mean, they must be addressable, so it must be need to sort of know where people are for advertising. But the more region, especially in smaller countries, you want to have 20, 30, 40, 50 regions. So randomization works. Because if you only have like 3 regions in a country, you have this problem that one region contains Berlin and the other Osnabrück and Bielefeld. So then that's not really comparable in the end. So we try to get like 50 regions in Germany. And what we designed is an algorithm that sort of starts out with each city and then puts together these GMAs, we call them, Google Marketing Areas, in such a way that the regions are as large as possible, as small as possible, but the probability of people traveling from one region to the other is minimal, or at least low enough. And that is actually a machine learning algorithm in some sense that sort of looks for this right balance and assembles the cities into GMAs, into marketing areas, based on the information we have about how people travel, which advantageous if we are Google, we of course have information from advertising where people were seen, and we use so past information we have from people to inform the choice of these marketing areas. And we have a number of interesting algorithms for that.
Indeed. I mean, just saying that makes me smile, because it shows how much thought and how much work goes into that. Because it's not like this. It's not a project where someone thinks, "Hey, we need to run Geo experiments because we heard about it now on this podcast, for example, or somewhere, and we just do it." Again, the whole process that you are working right now, it's basically built up on work that has to do with so many years and so much effort that has gone into it.
Yeah. So the algorithm I'm using is based on spectral clustering, but even that is that has like 30, 40 years tradition, but it's the first time we're applying it to this problem, and it's sort of even a surprising thing that in the beginning we did not really expect that it would be such an algorithm like that. But it works. So that's the interesting thing. In the beginning, it was quite hard because original way we were creating these GMAs, marketing areas, was we would start like with one, basically would calculate between the different cities how closely they're linked, how often people travel from one city to the other. So if you're in a large metropolitan region, that all the smaller cities outside of Hamburg are strongly linked to Hamburg. People commute here for work. So it would start a simple algorithm, so that's a little bit like clustering. It would start with like 2 entities that are most closely linked and would form the first cluster. Then would continue and do agglomerative clustering more and more. Then we got what was called the blob in the Netherlands, for example. You would start with Amsterdam, and then you would add more and more smaller cities, but it would just be the cities right around Amsterdam. This blob would go larger and larger, and at some point cover the whole country. So it did not give us any useful split of the country, because at some point, if like Amsterdam is already big enough, then the most logical choice was the next small city should belong again to the Amsterdam cluster. So now we do it the other way around. We basically start with the whole country as one, then find a way to split the country down the middle into 2 clusters that are about of equal size, and in such a way that they are sort of least contaminating. Which, for example, in the US, if you do that in the US, we certainly get a nice split that splits the western part of the US from the eastern part in the traditional way it has always been displayed. And so for data scientists, that is like the nice surprise that if you design this algorithm, then run it, and then suddenly the results actually make sense. They look like what people would have expected. It looks then at some point easy, but after the extent we went through to get GMAs, and especially in very dense regions like the Netherlands, it was quite nice to see an algorithm that I have this movie that I showed the talks that sort of splits the country in the middle, and then it starts splitting 2 halves, and you sort of see even the traditional regions coming up. So for Germany, the nice thing was, and long ago I showed that to a friend who comes from the Bodensee area, from Konstanz, and he noticed that our GMAs actually have the classical distinction between Baden and Schwaben, which goes along the Schwarzwald region. So that was very important for him, because we were always going, so you're from Baden? No, I'm from Baden-Württemberg, but actually from Schwaben. And in DMAs, you could clearly see that because these regions sort of were defined by, the one was more around the Rhine, the other was on the Schwäbische Alb, the plateau. And obviously people don't travel that easily from one part to the other. But then when put together as a political region, it ended up in one region. And from the north, I have no idea. They come all from Baden-Württemberg. But there it's a very strong distinction. It's sort of fun if you then suddenly see this distinction coming up in the data.
But that's at the end goes back to kind of data storytelling. I feel like mixing what we see in the data with actually the perceptions what we have in real life and bringing them together. And I think that's also one of the rewards working in data, when you can put those things together and you actually have this anecdote sharing with a friend or something. So that makes the whole work with data.
I love working with the geodata because we do that with different countries, and you learn a lot about the different countries while looking at their geography and their geographical data. So, and it's also sometimes so interesting. The US, for example, whenever I see a plot of the US, it's the middle of the US is basically empty. So there's the left side and the right side. In the middle is a huge empty region. When we do the GMAs, we notice that because basically there's nothing happening there. On the other hand, first experiment I worked on was in the Netherlands. So to explain that to an American, running an experiment in the Netherlands is basically running an experiment in the Los Angeles area. They are about the same size. And then, of course, they were asking us to do a geo-experiment in the Netherlands, trying to split the Netherlands, which is a region that's like Southern California. So they're completely different scales. And the Netherlands experiment was the one that prompted us to create a new algorithm that would try to do the split from the top, because there's one city after the next. There's basically one huge conglomerate of cities along the coast. They call it the Randstad even, but that basically covers the whole country. So yeah, it's quite interesting what you learn about countries in that.
Indeed. I remember now a project that I have worked on also with a supermarket chain, and they were focusing on advertisement only on a zip code level, because that's how the marketing department worked. And what we tried to understand is, from each of their location, they kind of found out through some surveys that customers that shop in the supermarket usually don't, in some, not in cities, but some suburban areas, don't travel more than 30 minutes by car to the next supermarket. So therefore, we kind of create the geo-fence around the different supermarket areas and try to understand which are the zip codes that actually fall into that region. So we don't have to target any, let's say, zip codes that lie out of this geo-fence. Yeah, so basically that was my work on with geodata. And again, it's, I think, also very interesting because you can plot it on the map, you can see it. It's a complete different way of working with it.
But the zip codes are, postal codes, zip codes, are interesting in the sense that they are designed from the postal office to deliver mail. So they are not actually made for advertising. So in some places that works and sometimes it doesn't work. We always have problems when we define then the marketing areas, the GMAs, they asked us for the list of zip codes. And I had one problem, then a client came back and saying, yeah, but we see a lot of orders from these zip codes and they're not included in your list. US, and start looking. Then the point is that in this, and you look at each of the zip codes separately and start to Google them. So it turned out there's a reserved number of zip codes for the military. I think they're basically in the numbers, they're close to San Diego because there was a huge naval base there that I guess made deliveries in there. They don't tell you where the military base is. It's just a number that means Army military zip codes. And of course, they are not in our list because we don't know where they are. So they were not in there, but they look like normal zip codes. So the client didn't even know about that. They just noticed, where do we put the zip codes? So I learned, okay, there's certain zip codes that actually don't have geographical thing. Another one was really suspicious because that was a zip code where they said there was a huge number of orders from the zip code and we don't know where it is. And then you could look it up. So maps actually came up in Seattle, in the harbor area of Seattle. And I was wondering what that was. And then you look at the web, who is actually using that zip code? And it turned out that was a zip code used by a company that offered shipping services for foreigners buying in the US. So if you were in another country, you would use their service and have the product shipped to their zip code, which was a large warehouse in the harbor of Seattle. And they would then forward it to you internationally. But it would allow you to buy products that you couldn't buy internationally, especially when you came from other countries where the retailers would not ship to. And of course, that's not a geographical zip code, but the retailer that we work with saw that a lot. Well, even compared to other zip codes, there were a lot of people using this one single zip code, and we're asking what it is. So zip codes, in some sense, a nice geographical entity, but you have to keep in mind they are not being meant to sort of for geography, but really for postal delivery. Some zip codes can be huge, some can be quite small, especially in larger cities in the US.
Indeed. I think that was a great excursus talking about geo-experiments and even about zip codes itself. If someone wants to dig more deeper into the topic of geo-experiments, do you know any good resources to start with?
Yeah, you can go to your favorite search engine and put in the word Geo-experiments or Geo-experiments Google. And I think we don't have a direct link or anything like that, but our team has published a few papers. So the one algorithm is called Trump Match. At some point, hopefully I managed to publish the algorithm I'm using for creating the GMAs. There are also a number of packages available in Python and R to do the experiments and to analyze the experiments especially. So that's usually a good place to start. And of course, if you are a larger client, it's always a good idea to talk to your client team. And if you want to do the geo-experiments, they can get you into contact with specialists who can help with that. And in the future, in 1 or 2 quarters, I hope that some of the geo-experiment functionality will be available even in our products for self-service.
Very interesting. One last question that I like to ask my guests on the show, if they have any, let's say, data or marketing secret that they can share. With this, basically, I mean, it's either a positive or a negative learning throughout their career. And I think you probably, who have worked in data, maybe you have more a data secret than a marketing secret to share.
Yeah, I'm not sure it's not a secret, but the thing that I learned, especially in geo-experiments, is that data part is really hard. So to design our geographical regions, I rely on the database that powers Google Maps, which is very well curated. And still, even after a few queries, there come all sorts of interesting mistakes. Even in the US, where it comes from, there are weird places that turn up. I think there was one that was right on the American-Canadian border. And then, because we were interested in things nobody else was interested very much, like which county does the city belong to, which we don't need normally that much. And we're running these queries and seeing all sorts of inconsistency. So the thing I learned that even in a very well curated database, there are lots of irregularities you have to deal with. And, basically everything that's in there is possible. I always have the story that long ago I worked on a database, other project, and there were like 4 flags in there that were coding the type of record that was in there. And there was like 10 possible combinations of these 4 flags, and they were binaries, or booleans. So it could be true or false. So of course there were a total of 16, but only 10 of them were legal. A simple query in the database, all 16 came up. Because the problem with databases is often that software you can fix. And can even write a new version of the software, make things simpler. But once things are in the database, they have to usually stay in there. And if you then have had a bug even years ago that put in a record with a mistake, you actually have to write a second program to fish out these records and fix them. And most people don't do that. So in some sense, that's maybe also a bit of a distinction between statistics and data science. Statistics is sort of a core part where you do the analysis, but the data science part has so much to do with just fixing the data, getting the data right, finding all the interesting things that people put in the database, which I usually have quite enjoyed. So I'm in that sense a data nerd, so it's really interesting. You can hear my zip code stories. I find it fascinating to see this representation of reality in data.
You have to be a data nerd to talk about things like you did with so much passion and fun and always with a smile on the podcast. Because, again, for some people it might be dry, for other people it's the completely opposite. So overall, I want to say, Christoph, thank you so much for sharing your knowledge, your wisdom, and again, even your insights about zip codes and about the database. I really enjoyed that conversation. And again, thank you so much.
Yeah, thank you very much. It was really nice. It was quite fun. I hope it worked out.
Probably. I'm pretty confident. Thank you again.
I've never done that before.
Thank you for joining us on this episode of the Data and Marketing Nation. If you want to put your marketing data to action, head over to vanalize.com. I wish you a wonderful day and see you on the next episode.